Everyone. Now for a session from Lemongrass on using DevOps automation for SAP on AWS. Just a quick introduction. My name is Eamon O'Neill. I'm the CTO of Lemongrass, and also on the line from our EMEA business development team is Rob Antons. We've got some contact details on the slide. If you need to follow up afterwards, feel free to reach out to us by phone or email or even by Skype. Just a quick introduction to Lemongrass and what we do. So what we are is very much an SAP-centric, but SAP technology-centric consultancy. And everything we do is to do with SAP technology. And really our key proposition is all about getting SAP technology to run on AWS. So we're an advanced AWS partner as well as an SAP partner. And what we've seen in the last 7 or so years since we started working with AWS is that while we started this journey quite a long time ago, we're seeing a really big uptick in interest in the last sort of 12 to 18 months. And our skills on getting SAP onto cloud are really helping customers get the outcomes they're expecting to see. But with some other technical skills that most SAP houses have around mobility, security, and integration, which really help us complete the story about how you run SAP on AWS. So that's what we do. We don't do any SAP functional. We steer clear from that altogether. And we focus purely on getting SAP customers onto the AWS cloud. We're about 90 people globally. All of our people are, most of our people are basis people who've cross-trained to AWS. We've got some pure play AWS experts and architects who help us on the slightly trickier stuff. But one of the new things with cloud we've noticed is that the basis people can cross-train into infrastructure and effectively take over the infrastructure operation role. And that's what we do for customers all over the world. We support them in different countries from different locations where pretty much all of our people work from home. We're probably the most experienced at getting SAP onto AWS in the world. As I mentioned earlier, we've been doing it for about 7 years now. And in that time, inevitably, we picked up a lot of customers, and we've helped migrate, I think it's about 300 SAP systems at this stage now. So we've seen a lot of different shapes and sizes. And in the very early days, some of those were quite small initially. Today, there's some very, very large landscapes that we're migrating to AWS. We've got a couple of really good case studies on the AWS website. I'll talk briefly about those in a second. And a key thing that we've learned over the time is that you need to bring automation opportunities to life. So a lot of techie guys can spot automation opportunities, but you need to really be rigorous about making that happen. So what we've done in our tool, or my cloud tool, is that we've created a repository where not only can we capture automation opportunities, but also we've got a whole process for identifying and automating those opportunities going forward. So what we've noticed is that for customers to run successfully on cloud, they need to change some of the things and the ways of working, and automation is a very big part of that, and that's what I'm going to talk about today. Just to see what some other customers have done and are doing, Friesland Campina is a very large dairy company in the Netherlands. One of the projects we started with them on was moving some mothballed or legacy SAP system to AWS from their data centers. So they are currently replacing up to 20 different ECC systems with a global consolidated ECC. And because those old ones were left behind, they were sitting in data centers and costing quite a bit of cash to run those and host those with the hoster and partners. So what we did was we took those systems, put them onto AWS in a static state, in a way where we don't have to patch or maintain them in any way except for some security patching. And then we put a portal on the front end of that solution so that any end user, so not IT, but any end user, could self-serve and start the systems and any dependent systems themselves on demand. And then once they're finished, they could shut the system down. Once they finish their query, they could shut the system down, or a scheduler would knock it off at night. So in other words, the uptime of these systems is very, very low, reflecting generally what people see when they try to use a legacy system. It's very rarely used. The upside is that by doing this, Freeze and Campina saved almost 90% of the run costs for those systems. And over the retention period for the systems, they'll save over 11 million euros. So the automation there is quite simple. It's creating a portal that people can authenticate into, writing some scripts that allow us to start and stop the systems and any dependent SAP systems. So really simple bit of automation producing an incredibly good ROI. With Coca-Cola in Turkey, Coca-Cola İçecek is the 5th biggest bottler in the Coca-Cola group, and they bottle for all the markets from Turkey east to Pakistan. And they were running a landscape on an IBM-hosted data center, and were struggling with capacity and cost. And we migrated them onto AWS. And for them, the initial thing they saw was an immediate cost saving, so up to 60% saving in run costs, but also real agility in getting things done. So from the first POC through to the first production go-live was 3 months. With the HANA migration, so they moved from BWA to BW on HANA, and we did that 2 weeks ahead of schedule. And what we've seen is that what Coca-Cola started to notice is that the speed of provisioning and the speed of system copies is really beginning to help them in their projects and in their finish their migration and do upgrades and other subsequent projects. So Coca-Cola, who have been live since 2016, January 2016, so running now for roughly 16 months, have seen the immediate benefit of cost saving, but are now beginning to see the next step, which is agility. And then the third case study, which is further down the line in maturity, is SECO, which was our first ever production migration to AWS. And again, what's nice about this is you can see the same sort of life cycle that most SAP customers see when they first adopt AWS. So SECO went live in January 2015, so they've been live now for over 2.5 years. And not only again did they see the big cost saving, they saw a dramatic performance improvement, whereby every month they were invoicing for over 2 million containers, and that was taking 4 days on premise. Once they had moved to AWS, we did some bursting for them onto AWS capacity, which allowed them to run that same billing run in less than a day. So for SECO, that was a huge benefit, not just in terms of customer service by getting invoiced out quicker, but also simple working capital, that things that are issued quicker get paid quicker. But for them, they saw a big saving in cost from day one, over 50%. But the performance was really what sort of impressed them. But what's happened to them since is that they've started to look at the next steps. So again, they have scheduling for non-production systems to come up when they need. They have done numerous system copies where they can, using MyCloud automation, they can provision non-production environments to run things like upgrades and patching, etc., in prior to hitting the BAU landscape. But also they're beginning to play and do POCs with the AWS IoT. We're now looking at Leonardo and some other more advanced feature sets with SECO. And part of the reason they're able to do that is because the SAP landscape runs very stably for them right now. So I suppose 3 case studies to show you the life cycle of what happens with customers as they move to and operate on AWS. And really what most technical people like to look for are those automation opportunities and what can you bring to life. So AWS, and it's a key characteristic of public cloud that it should be programmable. AWS has an open API, which is publicly available, very simple to pick up and start to use. And what we see are some very clear automation opportunities around everything from SAP installations, backups, DR recovery, on automating the recovery, scheduling, as I've spoken about a few times, but even things like SAP basis checks. One of the things we do as a managed service is we do basis checks for customers regularly. And what we're trying to do is automate as much of that as we can. So it reduces the amount of manual activity, and as you would expect, then will reduce the cost of that managed service. So we look at everything and see what can we do to automate it. But customers who are starting out will look at these initial things. And what's very simple, for example, you can get from the AWS website already, is what they call AWS Quick Starts, where you've got cloud formations you can effectively double-click on, fill out some parameters, and it will not just provision the AWS infrastructure, but also SAP software. There's also the Cloud Application Library, which does the same thing from an SAP point of view. The Cloud Application Library has I think it's something like 60 products that are available for AWS, and those range, from Solution Manager through to the latest S4HANA, BW for HANA, etc. So it's a great way to try things out, and for prototyping, leveraging the automated installations and the different options for that really accelerate and reduce the cost of trying things out. But one thing that we were really keen on addressing was the whole concept of SAP release cycles. And it's really because we've worked in SAP for so long, and we've worked in the projects where customers get very frustrated with the pace of change within an SAP landscape. So what we often see are customers who take a project-driven approach to releases. In other words, whatever project gets there first takes over the dev environment. And then what happens often is that dev environment is used really for prototyping, where the ABAPers and the configurers will try things out, try out a requirement spec that might have been documented or may not have been documented. And ultimately, that prototyping not just leads to a slowdown of the build cycle, it also means that some of the config that isn't needed to be promoted to cause is actually left behind. What tends to happen is as you move out of that dev environment to test in QAS, there's a break fix defect cycle where things that might have looked like they worked in dev don't work in quaz, and that's often because of the differences between dev and quaz. But again, that slows down the speed of the project. And what tends to happen is because they're behind schedule, the projects are forced to go live and often will go live ahead of complete and rigorous testing. So sometimes defects can even make it to production because the timelines are under so much pressure. But that's not the worst thing. For me, the worst thing is what happens to the innovation that doesn't make it into the cycle, because often what will happen is, and the business people will identify improvements that they want to see. They'll make suggestions, but often they'll be rebuffed and told that simply they don't have priority because there's a big project in flight and that project has priority. Therefore, they need to wait for potentially 3, 6, 9 months before they can get into a release. And what happens is that backlog of innovation not just builds up, but after a while, people stop suggesting the ideas because they recognize that innovation is never going to make it to production in any sort of reasonable time frame. Now, people introduced N+1 as an option, so in other words, another dev quaz. And again, that will help, but only in the short term, because very quickly, exactly the same thing happens to the N+1 track as happened to the single track. So we had this conundrum, and I've designed release strategies for customers where we scratched our heads about how can we get around this problem that there just simply aren't enough environments to deal with the demand of change and projects and innovation that's out there. So we recognize this problem. It doesn't affect everybody in SAP, in the SAP community, but it certainly affects a lot of customers. So what we recognized was we need to change things. So the first thing that I recognized was that we need to change the way people develop. So this goes to the core of the release strategy. So people should not be allowed into dev unless they know what they're about to do. So in other words, it should be a formal build. So they should come in with some tech specs, some functional specs, and potentially some test results. And only when the release manager sees that will they allow the project to start building in dev. By doing that, it means that they can build much, much faster and much more cleanly. So they can get through dev quickly and get into the QA environment where, once again, because they know exactly what they're doing and they may have pre-tested or should have pre-tested, they can execute the testing knowing that they're more than likely to get through that with positive passes first time. And what that means is the release cycle can be quite quick. So the release manager can reduce that to potentially anything from even 1 week to potentially a couple of months, but something that's a big improvement over today, wherever that might be. So by having a fast release cycle, the release manager can say to anybody, well, if you've got an innovation or a project that's ready to come in, I will get it through the release cycle in X weeks. And of course, the downside is if you're not ready, then you need to wait. But of course, if the release cycle is quite quick, then the pain of missing that first release cycle is not that bad. So people will take more time to get it right, knowing that the penalty for missing a release is not that onerous as it might have been previously. But then the challenge becomes, okay, well, that's a great idea, but where do people try things out? And that's where AWS really stands up. So what we needed was to provision environments for different project teams that could be self-serve, that would be metered, and there would be no limit on how many they could do. So the first thing was, that can only be done on public cloud. I'll explain why in a second. But the second thing was we identified a fairly quick way that we could automate using MyCloud the cloning of production into a non-production environment. And as you see here, the MyCloud will effectively take from either backup or clone or directly from production. It can clone it into what we call a sandbox environment. That sandbox environment will be tagged with the project code of that project. And there's an approval step as well. So what happens is when you request, and you might say, in production you might have ECC, BW, and Portal. For this project, you might just want the ECC environment. So in MyCloud, you select the systems you want. They get tagged automatically with that project code and approved for creation by the budget holder. You can do multiple of those in parallel. And indeed, if you want additional environments, you can have a sandbox potentially and even a test environment as well if you feel it's quite a large project. And then each project can take their time to do their own prototyping, but importantly also do the build, the informal build, the informal test, and get to a point where they really know what it is they're building. And they're able to create tech specs, functional specs, and test results that they can then show to the release manager to say, yes, I'm ready. So once a project is ready to get into release, they're able to take their changes into dev, and at that point they can then delete this environment from their account altogether. And the billing, of course, stops once you've deleted something from AWS. You no longer pay for it. So that metering means that the charges are only for the life cycle of the informal build and test phase, and that's the incremental in order to get to the release cycle. So by doing this, suddenly the conversation begins to change for the release manager. So no longer is the release manager's job trying to manage who's getting access to what environment when, and what state is the environment in, and what are we going to use it for. So I've seen it many times where release managers are juggling on production environments. They're struggling to get copybacks from production to QAS, and they really spend a lot of time pulling their hair out to manage a large landscape. With this approach, the conversation changes to, it's no longer an issue of do we have enough environments, it's how many environments do you want. And with AWS, that can be, in effect, an infinite number. So you can say to the business, tell us how many projects you want to run and how many environments you need, and we can provision it for you on AWS. So just got a question on, are these, I think it was back to previous question, I'll come back to later about the migrations we've done. I'll come back to that HANA versus non-HANA in a second. So the concept of using AWS to provision non-production environments temporarily, which take the pressure off the BAU track, it's not quite the code branching DevOps that we know of, but it certainly moves a lot further along the curve to get to that. So in other words, as you push more of the informal and design work to the left-hand side, you can then begin to focus on a standard approach that not only can you repeat for every single release for dev and cause formal build and test, but then you can start to automate. And this is where it does begin to look much more like classic DevOps, where you can automate the release of a package of work rather than manually pushing it through. Now, it takes a while to get there, and not every customer will be ready to do it all in one go. But what we've seen is that for customers like Britvic, for example, for them, this is quite an easy thing to start with. So their experience is they log on to MyCloud, and for example, here you'll see a list of different systems from ECC, Portal, Livecache, SCM, etc. And they select for example, here, 2 different products that they want to provision. It fires up a request for tagging groups if we want to provision this in an existing or new VPC or subnet, and effectively create a network isolated copy of that production system or set of production systems. Then the next step they'll be asked for is a PO number or a WBS or cost center number, some sort of and once it has been approved, then there's an automated creation. So what this gives is you can quickly gives you that enterprise control, which simply is making sure A, there's a cost control and tagging, so you know what's going to be spent, but B, there is a budget set up against that cost control, so you can report, are you actually spending what you said you were going to spend? So with the system copy, we've built in that control, but that means then we can give the release manager and the project managers the freedom that if they can justify the cost, they're allowed to provision the environments themselves. So the outcomes then, for example, within Britvic in the UK, for them a landscape copy, which previously was taking them 6 weeks, and they have about 9 or 10 products in that landscape. And that was really to provision up to a copy of what they have today. And now with AWS and MyCloud, they can do that within 6 hours. Now, the nice thing about that is the cost of failure is much less. So if you request it and then recognize you don't need it for whatever reason, you haven't spent 6 weeks of people time, nor have you spent any CapEx on new hardware. With AWS, it's as simple as selecting and deleting those environments again to get rid of that cost. So the cost of failure is very, very small compared to on-premise. But the second thing is the release cycle. So Britvic started with a project release cycle, which was completely variable, but certainly they suffered from that innovation backlog. And for them, getting it from probably somewhere between 6 and 12 months, we're now getting that down to 6 weeks, and that's still in progress. And part of the reason why it's still in progress is, like any IT change or IT project, the tool goes so far, but there's also a people impact. So what we're talking to people about is not just the release manager job changes, so they need to know what it is they're going to do, and the release strategy changes, so the way people develop and build changes, but there's also new tooling, so there's ways to automate testing, automate transport management, etc. And there's new processes that go along with that. So there's actually quite a change in the release strategy overall that should accompany something like this. But the good thing is that it's using AWS to break the current constraint on infrastructure availability and infrastructure scale. So once that's broken, you then need to update the release strategy, which means there's a people impact, and that's what we're doing right now with Britvic. So if we look back as to why does it work so well on AWS compared to trying to do this on-premise or even in quotes a public or a private cloud. Well, the difference between public cloud and private cloud and public cloud and on-premise comes down to 3 key characteristics. So first off, there's got to be a public API. So it's got to be programmable. That allows you to put in your own process controls rather than living with what the hardware or the VM hypervisor does itself. Secondly, it's got to be metered, I've mentioned already. You've got to be able to benefit from temporary usage and from optimization of that usage. Tagging is a key part of that, and a utility type billing model in order to produce a cost at the end of the month or even in real time is essential for enabling proper metering. And the third thing is infinite capacity. So we want to say to the business, there's no delay on provisioning any type of infrastructure you want. It's simply a matter of programming it and approving the request. Now, AWS is the best in the market at this because of it's probably got the best of each of these features. So first off, from a metering point of view, not only does AWS give you clear, hourly metering for all the components, the tagging works at all levels, and you're able to quite simply set up budgets against those cost codes and very quickly get control of your usage. Even for large HANA systems, so for example, SAP on HANA can now run on the X1E32X large, which is a 4 terabyte instance. That is still billed by the hour. So if you want to try that out for 6 hours, it'll be metered for that 6 hours and you will only pay for it. With other clouds, you sometimes get caught in for temporary usage, caught in full when you're commit. So with AWS, you've got the best metering. For infinite capacity, AWS serve, but also in provisioning the right SAP instances in all regions very quickly. So rather than there being a long delay between, say, the US getting the latest SAP HANA instances, it's a very short gap between it arriving in the first set of regions and the last set of regions. So the capacity is not just available quickly, but it's the largest capacity of any cloud provider. So you can feel very comfortable that you will always get as many environments as you want and as you need. They've got by far the largest of partners develop on the AWS cloud, so much bigger than anybody else. And the reason that benefits you is that the API matures faster, so it does what people really need it to do. And we can certainly see that right now, that everything you need in AWS is addressable through an API. That means that not only will Amazon innovate faster with their own products, but you will see great innovation from the partners in giving you tools to do your job better. So all in all, the three things that we define public cloud by, and in vertical as the true cloud, it's based on those characteristics, and those are really important for SAP. And AWS leads the way in all three. So the last step, and I mentioned briefly about it with Britvic and the release strategy, but it's certainly true for all cloud adoption, and certainly when you get to automation on cloud, is that there's a big impact on the target operating model. So the simple sort of phrase is, if you treat AWS like another data center, then you actually won't. So there's a very high risk that you will end up spending more money, and it can be, your IT processes could actually be worse and slower than they are today. So you've got to be very conscious that when you enter into a cloud migration and operating SAP on the cloud specifically, that you need to look at a number of items within the way you operate. And that ranges from, as I mentioned earlier, some tooling, for example, something like MyCloud, or there's other products on the AWS marketplace, and AWS partners are releasing products all the time that help you manage cost, help you manage IT processes. There are different roles now. So within the SAP world, what we see is the SAP basis role is now merged with the infrastructure role. So all of our people, as I mentioned earlier, are cross-trained AWS, and that is quite a structure, which not only means that it's less people, which is great from a cost point of view. From a performance point of view, when you've got one person or one team doing changes to all layers of the stack, it tends to happen faster, and people are better informed about what state each other component is in. A really big one, though, was governance. I would certainly stress that the implementation of SAP on cloud has to be very deliberate, and you have to be very clear about both the business case and cost point of view and any other benefit you're trying to achieve, that those are actually delivered. And what that comes down to is ownership of those outcomes. And because these are cost and IT agility, often the ownership is not clear today. So the cost is no longer procurement cost. It's actually an IT cost management role, which is a new role. And we call that financial architecture. But that financial architect owns and governs the financial outcome of the cloud adoption. And similarly, on a agility point of view, this is where we get to things like the release manager and the managed service manager. Their job is to speed up the IT processes so that IT is more agile and hence the business can be more agile. So the target operating model, while it's often considered a post-go live issue, it's actually fundamental to achieving the outcomes. And what we say is even for release management or DevOps, as we just talked about, probably the biggest impact on making that successful is ensuring that the ownership and governance is there to take it. Hopefully that covers at a first pass level. For you to tap them into the question box on your right hand side, and as I mentioned earlier, if you prefer to drop an email to Rob or I, feel free to do so. Just answering a couple of questions that have come up. One is, are all of the migrations to cloud so far based on traditional DB or HANA? Well, a lot of them are HANA, and what we're seeing at the minute is that HANA is certainly becoming mainstream. So, for example, we see here a number of customers are starting on HANA. So LeasePlan in the Netherlands is a greenfield implementation, and I think 4 of their business suite applications will be running on HANA. We've seen quite a few customers move into BW HANA. That seems to be quite popular now, and there's a clear business case for that in terms of removing something like BWA, for example, but also just getting performance improvements. We've certainly seen successes with that for customers. And then finally, we're seeing some customers now moving to S4HANA. So greenfield implementations of S4HANA is a growing curve, and we're seeing that that's certainly in early stages, but ramping up. Cool. So any more questions so far? Cool. Okay, well let's wrap it up there. As I mentioned, if you have any, if you want to get in contact, talk about what we've just covered off, the DevOps on AWS and how to leverage AWS to bring that agility to SAP, you feel free to reach out to Rob and I or via AWS, and we look forward to speaking to you then. Thank you for your time. Goodbye.